Hello friends, in this video we are going to discuss that in what kind of molecule or structure of a molecule we can observe resonance. Okay, so basically we can identify resonance in a molecule. Okay, so for that we have to first understand what exactly resonance is. So resonance is basically delocalization of electron, delocalization of electron. Okay, so delocalization means electron will not be placed at one place or will be localized at a particular space. It will be moving from one space to another space. So delocalization is basically movement of electron, movement of electron, and what kind of electron will move and where they will move, that we need to know. So first thing is that in resonance only pi electrons are delocalized. Okay, so this is basically delocalization of pi electron in parallel p orbital system, in parallel p orbital system. Okay, so parallel p orbital system will have almost same energy, so that is why electron can move from one place to another place. So now what does it mean, this parallel p orbital system, and where we will see this system? So this parallel p orbital system, it is called conjugated system, conjugated system. So in conclusion, we can say that resonance occurs in a molecule in which we have conjugated system, right? So, and now you know that conjugated system is parallel p orbital system. Okay, this parallel p orbital, this p orbital could be, this p orbital could be unoccupied, or you can say vacant, or maybe occupied, fully filled, fully filled, or partially filled, or it has one unpaired electron. In all cases, we this p orbital will participate in resonance. Okay, so now we will see conjugated system, right? Types of conjugated system. So first and very popular one is alternate pi bond. So whenever you have alternate pi bond in any molecule, you can say that resonance will occur. For example, if you have uh, alternate double bond, C double bond C. So I'm not showing all the bonds associated with every carbon. So, but the tetravalency is of course satisfied for all the carbon. So you can have alternate double bond, you can have alternate triple bond, or maybe alternate double and triple bond. Okay, it can happen between a double bond between different atom also. Suppose you have double bond, single bond, double bond, then here also resonance will take place. Okay, so this system is parallel p orbital system. So I will just draw the orbital picture of it so that you can understand it very well. Suppose you have these four carbons, and these two are forming these two are forming pi bond with this overlapping, and pi bond with this overlapping. So you have one electron in every p orbital. Okay, so these four p orbitals will be in the same plane. Okay, then only we can say they are parallel p orbital. So now how can we draw the resonating structure and what exactly is happening in this? So here what will happen, that these electron will be moving. Okay, so if you move these two electron like this, then this electron into this, and this electron into this. Then what you will get? You will get this C. I'm drawing p orbital, and here you will get 2 electron. So it already had one, and one more will move, so it will have 2 electron. Here 1 electron, and here 1 electron, right? And this will have empty p orbital. Fine. And these two will form bond. These two are forming bond because it has got one unpaired electron, so they will form a pi bond. So this structure is basically C double bond C, and C with a lone pair. So here you have vacant p orbital, so you can say that it is a carbocation, and here it has lone pair, then it will be a anion. So basically what you have done, you have converted this structure into this if you move electron. So basically this structure is converted into this structure. Okay, so you can show this movement like this. So this pi bond pair electron will become lone pair, and you will get carbanion, and this pi bond pair will come here, and this carbon will have empty p orbital, so you will get carbocation. So this is how you can draw the resonating structure. Okay, so wherever you see this type of system, you can understand that resonance is taking place. Now next one is, if we have pi electron, pi bond, and alternate positive charge. Okay, so let's take this example. If you have C double bond C, and then you have carbocation this. So here you can observe resonance, and you can draw resonating structure like this. This pi electron will move here. So you will get carbocation here, and then C double bond C. Always remember that in resonance, electron moves from high electron density. Movement is always from high electron density to low electron density. Low electron density. Always movement takes place like this. So here you have positive charge, so electron density is less. Here you have double bond, so electron density is more. So let's draw orbital diagram, and then it will be very clear for you guys. So yeah, so I will just remove this pi bond. So here you have this. So this is carbocation, so you have empty p orbital. Here you have double bond, so you will have one electron like this. Now what will happen, that electron will move from here to here, and like this. And then what will you get? You will get C and now you will have one electron here, and then this is empty, and these two will form bond. So you will have C double bond C and empty, so carbocation will come here, right? So you can draw here hybrid also. If I draw the hybrid, so it will be average of these two structure. So hybrid would be like C, 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 partial double bond, and then plus half charge here, plus half charge here. So why I'm taking plus half? Because both structures are equivalent. Okay. Next type of conjugated system is pi bond alternate with negative charge. Okay. So mostly this negative charge will be, this negative charge could be carbanion or O minus or N minus. Generally you will come across these type of anion in organic chemistry, but it can happen with any negative charge. So what happens in this, again I will take C double bond C and C negative carbanion. So in carbanion, carbon will have one lone pair. So now if you see electron density here is more, compared to here, because you have negative charge compared to this part of the molecule. So movement of electron will be like this. So what is happening here, that this lone pair will become bond pair and this bond pair will become lone pair. So you will get this type of a structure, and then negative charge will come here. Again, I will draw orbital diagram for the sake of better understanding. If you guys find any problem, any doubt, you can ask in the comment section. So here you have one lone pair, you have two electrons, here, and then one electron here, one electron here, and they are forming pi bond. So if I see the movement of electrons, and then what will happen, this one electron will move here and one electron from here will move this side. So what will you get here is something like this. So this filled with two electrons, this one electron and one electron, and they form pi bond. So this is C double bond C here, right? And lone pair here, so you will get a negative charge. So I can draw now hybrid of this, and hybrid is C this, and negative charge on these two carbon. Fine. So here you can say the pi bond is alternate with negative charge, and there is lone pair also. So even if negative charge is not present but the lone pair is there, then resonance will take place. For example, this one. Now I'm talking about this. So for example, if you have C double bond C, and suppose you have OH, right? So here oxygen has lone pair, so you have pi bond alternate with lone pair. So here movement will take place like this. This pi bond will become this lone pair will become pi bond pair, and pi bond will become lone pair, and you will get this structure C double bond OH, and you will get positive charge here and negative charge this. So similar movement. Okay, so I need not to draw orbital diagram now. You orbital diagram again and again. Now you can understand it easily. So if you draw the hybrid of this hybrid, then you will get C partial double bond, and then you will have slight positive charge here, and H is, of course, H is present here, and slight negative charge here. So see why we are placing slightly negative, not plus half minus half, because these two structures are not similar. Okay, they are not identical, so their contribution will be different. So these two are different contributing structure. However, here you had similar structure, these two are identical, so that is why, or you can say equivalent, not identical, equivalent. So here you can say that the charge on these two carbon will be same, but here you don't have equivalent structure, you don't have same energy for these two structure. Okay, another type of conjugated system is lone pair adjacent to positive charge. So if you have a carbocation particularly, and then you have OH, and then you have lone pair here, so what will happen, that this lone pair will become pi bond pair, and you will get this structure OH plus. So here also you will see resonance. So here I will draw orbital diagram. So suppose this is carbon oxygen, and this is carbocation, so you have empty p orbital, and here you have uh, two electrons, right? So what will happen, that one electron will move from here to here, so you will get C with one electron, and oxygen with one electron. So one electron here, one electron here, so they will form a pi bond. So you will get a pi bond here, and since this oxygen is electron deficient, it is giving away one electron to this carbon, so there will be a positive charge on this. And if you draw the hybrid of this structure, then you will get COH, slightly positive charge here, slightly positive charge here. Fine. Another kind of alternate bond is basically you you have C double bond C, and then you have one unpaired electron. Okay, unpaired electron means you have, suppose, carbon free radical you have. Okay, so here also resonance takes place, and here if you have to draw resonating structure, you will just do this homolytic breaking of this pi bond. So you will get C C, one electron here, one electron here, one electron here, and these two electron will form a pi bond. So instead of putting electron here, I can directly write that here you will have a double bond. So see, basically what we are seeing in conjugated system, that if you have parallel p orbital, and if you have parallel p orbital in which one is empty, then also resonance takes place. Even this orbital is filled, then also resonance takes place. Fine. And if you have adjacent orbital, filled orbital, and vacant p orbital, then also resonance can take place. So this is all about conjugated system. So wherever you see this type of structure, resonance will take place there. Okay, so I hope you understood everything. Thank you.